Hello, my name is Kimberly Hines, and today I'm going to introduce you to the WeatherBot, an Arduino-powered weather monitoring robot, built and simulated entirely in Tinkercad. The WeatherBot tracks environmental conditions and alerts other robots like our SoilBot, AgriBot, and CoopBot to help them react in real time to environmental conditions. So let's take a quick look at the circuit. This bot is powered by an Arduino Uno and uses a variety of sensors to help this robot function. So the first one is the TMP36 temperature sensor. This will alert a user or other robots if the temperature gets too high. We have 4 potentiometers, a wind sensor, humidity sensor, and a rain sensor, as well as one down here on the display screen to help the display be more readable. We have a photoresistor for the light sensor to detect light levels. For outputs and alerts, the bot uses 2 DC motors to control the wheels on the robot, a piezo buzzer to alert other robots of environmental conditions. And we also have this 16:2 display screen that'll actually display readings from the sensors, calculate values like the temperature and humidity percentage, and then display those readings and trigger specific motor or buzzer reactions based on those conditions. So the first thing I will show you as I start the simulation is when the robot turns on, it'll let the user know it is ready by saying WeatherBot ready. So let's get this started. I'm also going to show the code here so that way you can follow along. So what's happening right now is certain conditions are being met and the bot is alerting other robots of those conditions. I'm going to go ahead and set everything to where you will not hear that buzzer for just a moment. As you can see, there is a change in the display. So I'm going to go through each of these sensors, kind of show you what happens, let you hear the buzzer, let you see the changes, as well as the code that is happening. So the first one we will do is this light sensor. This lets bots know if it's daytime or nighttime. So if it is daytime, meaning it is between 400 and 800 on the analog, this will display a D or an N for nighttime. So as I change the sensor, you will notice that this changes. Nighttime lets the bots know it's time to return home. Humidity sensor, shown here as a percentage, if it gets below 30, that indicates dry conditions and lets the robots know, specifically SoilBot, that it's time to amend the soil and increase watering. So let's wait for that to change. Okay, so humidity dropped below 30 and it alerted the other robots. The same thing will happen with the wind sensor if the wind gets too high or over 800. So as I change this, the wind will be recalculated as the loop comes back around. There we go. Same thing with temperature. If it gets over 90 degrees, it will alert the other robots. Let me bump this up just a hair. It's currently at 76.6 Fahrenheit. Now it is way too hot. And the last one is rain. This one will display 3 different values, either none, see here, none, high, or low. That's correct. Okay, so if I change this a little bit, we get a low reading, which should not trigger the buzzer, but if we get heavy rain, it will. Okay, so we have heavy rain. Oh, there we go. Now we have heavy rain. What you also see is that these DC motors have stopped. I'm going to turn that down for just a moment. So we don't want the bot moving while it is heavy raining. So those DC motors actually stopped for us. The last thing I want to show you is that these motors are actually on a repetitive cycle. So they're moving forward, turning left, going forward, turning right, stopping, reversing, and then stopping. And then it repeats this loop going through, reading each of the sensor readings, displaying it on the screen, and continuing on with its prescribed path. Thank you for watching. I hope you enjoyed this demonstration of the WeatherBot in action. Thanks.